Hey guys, so in chapter moving ahead in energy efficiency in thermal utilities and systems, we have seen many systems like boilers, steam system, furnaces, insulation, and refractories, and also at last heat exchanger. So now we will move to next system, that is how which systems which we can use to recover the waste heat. So waste heat recovery system. So how we can recover the heat. So as we know that prime mover uses fuel in order to generate energy. So fuel gets burnt in the burner and liberates the heat and runs the prime mover. So that prime mover consumes the certain percentage of heat and releases the remaining heat unutilized. And this heat may be released by conduction, convection, or radiation. Unutilized heat is another source of energy because it contains sufficient amount of heat which can be used for economic purposes. So the heat which is released as a waste is termed as waste heat. So that heat we are going to recover. So that is why the name of the topic is waste heat recovery. So apart from various prime movers, if we leave the prime movers, there are many applications such as regenerators, recuperators, heating, ventilation, air conditioning, that is almost all kinds of heat exchanger releases waste heat. So if by any technique, if certain percentage of such waste heat is being recovered, then considerable amount of energy can be produced. And this whole process of recovering the energy from waste heat is termed as waste heat recovery. So before moving to the topics under the waste heat, first question which comes to our mind is that which are the potential sources of waste heat which can be considered for utilization. So mainly 6 to 7 sources which we consider we will discuss. So first is heat from flue gases, so which is released generally in power plants. So that is one of the sources. Then second is loss of heat from exterior of the equipment while functioning. So while any equipment is functioning, so a heat is lost from that equipment. Next is heat liberates from vapor streams in cooling system. So if in cooling systems heat is liberated in the form of vapor streams, so that is also a source. The heat losses in cooling water, heat losses in chilled water, heat stored in products leaving the process, heat in gaseous and liquid effluents leaving any kind of process. So that are the main sources of waste heat. So we'll discuss So what are the topics in this we are going to consider, that is classification advantages and commercially viable waste heat recovery devices and its saving potential. So in this we have considered many topics, many potential devices are we are going to discuss, it is recuperators, regenerators, etc. So let's start with maybe advantages. So the amount of heat which is available depends on the temperature from where the heat is required to be reused. So also the technique used to extract the heat is also an important aspect of waste heat recovery. So what are the advantages if we recover the waste heat? So there are many advantages. So first of all, it is a direct impact on the utilization of fuel. So fuel usage used will be the requirement of fuel will be less. Utilization of fuel and reduces primary fuel cost. So it will reduce the primary fuel cost. Second advantage is released gases mostly having pollutant components such as carbon monoxide, nitrogen dioxides. If waste is recovered, then pollutants are reduced and environmental pollution level can be decreased. So, so when you capture the gases through which the heat is being dispersed, so so by automatically you are also saving the pollution by capturing this pollutant gases. So that is also a one kind of advantage. Third, that is since direct impact of waste heat recovery reduces the fuel consumption, the size of the equipment can also be reduced. So this is also an point according to economic, you can consider as economic point, or also you can consider as a flexibility point. Then fourth, other equipments can be used in parallel with main equipment, so other auxiliary small equipments are run without any input of fuel. This is at the best usage, that is whatever power you are saving by recording the heat, that power you can utilize for operating an auxiliary additional equipment to it. So that is the advantage is of recovering the waste heat. Now we will classify the waste heat recovery in various aspects on the basis of sources of heat only. So in considering the potential for heat recovery, it is useful to note all the possibilities and grades the waste heat in terms of potential value. So if there is a possibility to recover the waste heat, so we also need to see the grade of what grade the waste heat is being recovered. So here are the various sources of waste heat which we discussed also earlier. So for again we will point out and we will see the grade quality of this sources of heat. So first is heat in flue gases. So the higher the temperature, the greater the potential value for the heat recovery. So here the quality will be high generally, and more the temperature, the more the quality will be of waste heat. Then heat in vapor steams as above, but as above that temperature is high, so greater will the potential for waste recovery. But when condensed, the latent heat also recoverable. So latent heat can also be recoverable. That is an additional advantage. Then convective and radiant heat lost from exterior of the equipment. So in this, it is a low grade. So if collected, may be used for space heating or air preheats. So it can be used for heating only. You cannot convert in work. Then heat losses in providing chilled water or in disposal of chilled water. High grade. It is high grade if it can be utilized to reduce the demand for refrigeration. If you can reduce this demand, it will be high grade. The low grade, if the refrigeration unit used as a form of heat pump. So if for refrigeration it is high grade, for heat pump it is low grade. You can consider as it is. Then heat in gaseous and liquid effluents living process. Poor if heavily contaminated and thus requiring alloy heat exchanger. So what happens in gaseous and liquid effluents, rather than if we are considering the coal, leaving the coal, the other effluents are having heavily contamination, so it will require an additional alloy heat exchanger, so it will be very much problematic to get that heat. So that is poor quality of heat. So also you can consider one more, that is heat loss in cooling water. So it can you can consider low grade because useful gains in if heat is exchanged with incoming fresh water. So these are the main sources of heat and their grades. What are the grades of extracting the heat? So now we will discuss commercially viable waste heat recovery devices. So waste heat recovery from ventilation is known as HRV. Following are the these are the types. This following are the types of waste heat recovery system which uses exhaust gases of ventilation and recovers the heat. So we'll discuss each and every one by one. So let's start with the first one, that is a recuperate. Sorry, let's start with regenerator first. Regenerator. Let's start with regenerator. So regenerators are those kind of heat exchanger in which hot and cold fluid passes alternatively through space containing solid particles. So what happens in a regenerator, that once you passed hot fluid, so that hotness will be stored in the space, then you pass cold liquid, so that hotness will be absorbed by the cold. So that is kind of concept. So the solid particles alternately work as sink and source. So the design and material selection depends on the time between reversal process. So after how much time this process is being reversed. So it depends on that. So if the reversal process time is long, then material should be such that it should have higher thermal storage capacity. So that is the main crux of this regenerator. So as in this figure shows the application of regenerator as a heat recovery from ventilation. Certain factors such as reversal time, area of storage decides the material and size of the brick. If the reversal time is long, it will lower the average temperature and lead to loss of heat also. Consequently, it reduces fuel economy. Also, accumulation of dust and slagging on the surfaces reduces the efficiency of the furnace and becomes old. So the main application of such type of regenerator is where the exhaust temperature is very high, such as glass and steel melting furnace. So that is the main goal of a regenerator. Then we'll see the next is recuperator. So the working principle of a recuperator is that it is a device in which flowing fluids exchanging heat are on the either side of the dividing wall. So as you can see in this diagram, so inlet air from the atmosphere, so air you are inserting, and that air is being preheated from up to down. While so from where the air is getting heat, so the air is getting heat from the exhaust gases which are perpendicularly poured in and it is moving outside. But what's the catch here? So they are exchanging heat but they are not in contact. So they are having in between a dividing wall. So the fluids do not get mixed. So in order to recover the heat on either side, wet steam wet wet steam is passing, and on the other side of the air for combustion is being preheated. So due to fresh air is heated and hot gases are cooled down, most commonly there are these are two types of recuperator. It is convective type and radiation type. So in convective type, recuperator is similar to the shell and tube type heat exchanger. So this is a shell and tube type heat exchanger. So it is similar to convective type. This is convective type recuperator. So hot gases are passing in the tubes which have smaller diameter. So while the fresh air is passing from the shell. So fresh air is passing from the shell. Sorry. So fresh air will pass from the shell. So this is the shell, while the hot gases are passing in the tubes. So hot gases are passing in the tube. So as you can see, this is the gas outlet and this is the liquid outlet. So the gas are so the gases are passing in the tubes and moving out, while the fresh air is passing from the shell and it is moving in this direction. So The efficiency of such type of recuperator is higher compared to the radiation type recuperator, because in this type the fresh air comes in direct contact with the tube from where the hot gases are passing, and the efficiency of this type of recuperator can be further increased by increasing the number of passes in the recuperator. So the more number of passes, the more will be the efficiency. So now let's discuss radiation type recuperator. So it works on the same fundamental principle as in convective type recuperator. The major difference between them is the mode of heat transfer. So in this type of recuperator, the heat exchange takes place due to infrared radiation. So the heat is allowed to desired application. So when preheated air is supplied, so air is supplied to the application, the amount of fuel required to heat the air is gets reduced. So hence this significant fuel saving is possible. Also, when the fuel is supply is reduced, the quantity of exhaust gases gets reduced. Though this kind of recuperator is less efficient since there is no direct contact between hot gases and air, it is preferred where there is an application of high temperature area such as furnaces. So these are the main types of recuperators. So we will discuss the other types of devices through which we can recover the waste heat in the next lecture. So in the next lecture we'll discuss thermal heat economizer, waste heat boilers, and heat pipe, run on coil, and etc. So this was the topic, how we can extract the heat from the waste heat. So I hope you understood various aspects of this and what are the advantages, classification, and everything. So thank you very much.